As with any deep learning model, GenAI models rely on several key components, like neural networks, data preprocessing, training algorithms, and evaluation metrics, all of which contribute to the effectiveness of the model. Users of GenAI models can leverage their knowledge of the model's components to get more tailored, efficient outputs without needing to modify the underlying architecture or code. GenAI models are built from several core components that work together to generate outputs. At the heart of GenAI models is a neural network architecture, often based on deep learning. For example, models like GPT, BERT, DALL-E are based on the transformer architecture, which uses layers of neurons to process and transform data into meaningful outputs. These layers mimic the neural activity in the human brain, processing input data in a way that allows the model to capture complex patterns and relationships. Next, for models working with text, images, or audio, the input must first be converted into a numeric format that the model can process. This process is called embedding. It involves the input embedding layer, where data, like words in a sentence or pixels in an image, is represented in a vector space, capturing relationships between items. The model then uses these embedded vector representations to understand context and structure. Then, the layers of transformation, also known as hidden layers, are where the model does most of its processing. Each layer transforms the data slightly, uncovering deeper patterns and relationships within the dataset. For GenAI models, hidden layers often include attention mechanisms found in transformer models. These mechanisms help the model focus on the most relevant parts of the input to generate accurate output. Finally, the output layer generates the final result based on the model's understanding of the processed input data. For example, in a text generation model, this layer would predict the next word in a sentence. In image generation, it would predict the color or shape of the next pixel or section of the image. GenAI models learn by going through massive data sets to capture patterns, structures, and relationships within the data. This process happens through training, which includes several phases. During the pre-training phase, the model is exposed to vast amounts of data without any specific task. It learns general knowledge and common patterns from this data. For example, a language model might be pre-trained on millions of sentences to understand syntax, grammar, and vocabulary. This is usually done in a semi-supervised manner, where the model does not require explicit labels for the data, but learns from the patterns and relationships it observes. After pre-training, the model undergoes fine-tuning on a smaller, task-specific dataset. This step customizes the model to perform specific tasks better, such as answering questions, generating images in a specific style, or understanding specialized, domain-specific language used in certain fields. For fine-tuning, the model is trained with labeled data, where each input has a correct answer. This step helps the model get better at specific tasks by learning from these examples. Models get better with feedback and reinforcement. This involves incorporating feedback from people or using reinforcement learning algorithms, which are special methods that help the model learn from rewards and penalties. These techniques help the model's results better match human preferences or specific goals. GenAI models adjust their parameters based on errors they make during training using backpropagation, a method that updates the model by calculating and correcting errors in its predictions. To summarize, a GenAI model's effectiveness relies on several key factors. It starts with a sophisticated neural network that captures complex patterns. The model is then pre-trained on large data sets to gain a broad understanding. After that, it undergoes fine-tuning on specific data sets to improve its performance on particular tasks. Finally, continuous feedback is essential to refine the accuracy and relevance of its outputs. With these components and processes, GenAI models can generate realistic and innovative outputs across various formats, from text to images and even audio. Understanding each of these stages helps users and developers optimize models for specific tasks and ensure the outputs align with desired goals. As we refine these models, the possibilities for diverse and practical applications continue to expand.